This tutorial we're going to look at the unit circle, and this is just a small extension of what we did last time when we used a triangle at specific points of 30 degrees, 45, 60, yes, 90 and 0 as well. And using Pythagoras we found what are known as the standard trig values. And here they are displayed, covering the angles from 0 to 90 degrees and covering the three functions sin x, cos x and tan x. But what that doesn't show us is anything to do about the shape of the waveforms involved. We've got some points, yes, but we don't know the accurate shape. So this is where the unit circle comes in. Yes, we've still got a hand, and the hand is pointing at 3 o'clock, and the triangle that's going to be formed is squished right down to a horizontal line. Let's move that hand up to 30 degrees and I'll show you what happens. The crucial point here is that the hand that we're moving around this circle is length 1. So let's have a look what happens to the equations when we have a hypotenuse of 1. Okay, sine theta equals the opposite divided by the hypotenuse, which is 1. So that means the opposite length is just equal to sine theta. Equally, cos theta equals the adjacent divided by 1. So the adjacent just equals cos theta. And tan theta equals the opposite over the adjacent. So yes, that's unaffected by the fact that we've got a hypotenuse of 1 because it doesn't use the hypotenuse. So on this diagram here, the length of the vertical red line here, which is the opposite, is just sine theta. And equally, the length of the green dotted line here, which of course is the same distance as the adjacent because it's just down here, is equal to cos theta. So let's step through the progression from 3 o'clock to 12 o'clock in our standard trig value lumps, if you like, and you'll see what happens to the triangle shape as that hand moves round from 3 o'clock to 12 o'clock. 3 o'clock, flat as a pancake, the opposite is 0, cosine theta is 1. 30 degrees, sine theta has attained a value and cos theta has reduced in value. 45, there they are, cos theta and sine theta are now of equal length. Moving on further, sine theta really is growing and it's growing up towards its value of 1 and cos theta is declining, heading towards 0. Now the next move is going to be the 12 o'clock one, and there we are, sine theta now 0, cos theta now 1. But moving in those discrete lumps hasn't shown us anything about the waveforms of either sine or cosine or indeed tangent. But if we move that hand continuously, again in this unit circle, these waveform shapes will appear.